Hello all. Today we are going to start our trig ratios. Last class we started to identify the sides of right triangles. Today we're going to use those sides to find what we call sine and cosine. However, before we even get there, we just want to review similar shapes so we can start to understand what trig is all about and why sine and cosine work. Alright, so if we remember, a similar shape is one where we have a right triangle, and then we have another right triangle that is essentially the same but bigger. So what does that mean if it's the same but bigger? Well, what it means is that this angle here is going to be the same as this angle here. Obviously, they're right triangles because that's what we're dealing with. So that means they have those same angles. And if the orange angles are the same, then these angles are going to be the same. Because the shape is identical, it's just a little bit bigger. So our angles haven't changed. So we'll write out that. And then we also would have our side lengths. So let's say that this here is a 3, 4, 5. Okay, so if I have a scale factor of, let's say, 3, that means that each one of these sides is going to multiply by 3 and then be something different here. But everything stays the same scale factor. So this would be 9. This side here would be 15. And this side here would be 12. Now these are similar shapes. However, though, there's one thing that we can do. If we look here, we can take ratios of these sides to figure out what their angles are going to be, because the angles are all the same. If we look, this orange angle, like we said, isn't going to change over here, and this angle here also isn't going to change. Those are the same because they're similar. The only thing that changes is that we have a bigger shape in terms of the side lengths. So if we look at a ratio, we could say that, let's look at 5 and this 3, okay? So that ratio is 3 to 5. Well, let's look at this ratio of the same sides, only in the bigger shape. We have 9 and 15. Well, 9 and 15 just reduces down to 3 and 5. So what we can say is, if these two sides in any triangle reduce down to 3/5, then we know exactly that only corresponds to that particular angle right there. And so the whole idea of trig is to say, well, we can use sides and angles to figure out missing sides and missing angles of other places in the triangle. So again, what we're trying to say here is, because these are similar, they have a ratio. And anytime we see that ratio, a specific ratio, such as this one, 3/5, anytime that those two sides give us a ratio of 3/5, we know that they have to have a specific angle. Now, we don't know what that angle is yet, and we're going to get there, but we do know that they have to be the same angle, and so then we're going to start looking at these different ratios and figuring those out using our calculators, and that's going to allow us to find angles and side lengths eventually. So that's the whole basis of what trig is. It's all based on our similar triangles. So we noticed that last class, or last notes from Wednesday, we started to identify the sides of a triangle. And this is crucial because, again, we're going to be looking at a reference angle, and that reference angle is going to help us with our trig because that's what we're trying to find here. All right, so if we take a look here, we had a right triangle, which was the whole basis of last class, and the rest of the year we're going to be dealing with right triangles. And we had some reference angle given to us. Okay. So the first thing we started to talk about was our reference angle. Then we said, based on our reference angle, we're going to have two side lengths. We're going to have what we call our opposite side and our adjacent. Now the opposite side, right here, is opposite of the reference angle. And our adjacent side helps make that right angle, or sorry, make that reference angle. So we have our opposite and our adjacent. And again, we all should know now, after we've been doing this for a few weeks, this here is our hypotenuse. Which is always the longest side or the side opposite of the 90-degree angle. And so this is going to be really important that we know these three sides and the reference angle. So we have to be able to find our opposite, our adjacent, and the hypotenuse. And don't forget, these two are based on the reference angle. So they can change. They're not always going to be in the same place. It's all determined by that reference angle and where it is. Okay? The hypotenuse won't change because that's always based on the right angle. It's always opposite of the right angle of the longest side. But the opposite and the adjacent can flip depending on where that reference angle, which we call theta when we don't know it. It's kind of like a different variable for it. So let's look at our two trig ratios. We're going to look at sine and cosine. So we have our triangle here, and we have our reference angle. Okay, so that reference angle we said is a special one. So we have our opposite, we have our adjacent, and we have our hypotenuse. Now, like we said, with similar shapes, if we look at the ratio of the sides and they're the same, we know that means it's a very specific angle. Just like we said here. If we know that 3/5 is the adjacent and the hypotenuse of that highlighted angle I did, then we know every triangle that has a ratio of 3/5 is going to give a very specific angle there. So we're going to use that to our advantage, and we're going to say the sine of some angle, we don't know what it is yet, it's our reference angle, is always equal to our opposite side divided by our hypotenuse. So the ratio of the opposite over the hypotenuse is dealing with sine, and that's going to reference or give us this very specific reference angle. Our cosine of that same reference angle is going to give us the adjacent side over the hypotenuse. So there's two ways to look at that angle. We can look at the ratio of the opposite over the hypotenuse. That would be sine. Or we can find cosine, which is the adjacent over the hypotenuse. So again, sine is our opposite over the hypotenuse. So in this case, we would be looking at the ratio of these two sides to find that. That would be sine. Or we could use cosine, which is the ratio of the adjacent over the hypotenuse. So if we wanted to find this angle, but all we knew were the adjacent and the hypotenuse, we would look at this ratio here. So we only need two side lengths to really figure out any angle in a right triangle. And depending on what those two side lengths are, we can use sine or cosine as long as we have the hypotenuse. Now there's one other that we'll get into next class, but for now we're just looking at finding these ratios. So we need to know the sine and we need to know the cosine for today. So these here are very important for us. This is what today's lesson is about, is being able to find these ratios. So let's do a little practice here. So let's do two problems. So there's right triangle, and I'm just going to make these side lengths up. I don't know if these are actually right triangles, but we're just going to use these numbers as examples. So let's say this side length is 10. Let's say this side length is 14. And let's say this side length here is 19. Same thing down here. I don't know if these are actually right triangle side lengths, but we're just going to use them for our example. The ones you'll get in today's homework actually are right triangles in terms of the Pythagorean theorem working. So let's just do another quick example. Let's say this is 6. This is 12. And this guy here is 15. All right. And my reference angle I'm going to put on this one here is that side, or that angle. My reference angle on this one is going to be right here. And again, that reference angle is key because that's going to tell us what's opposite and adjacent. All right, so I'm going to go ahead and do this first here. So I want to be able to find the ratio of sine, and I'm going to have to find the ratio of cosine for this. And I'm going to do that for both of these. Again, feel free to pause and see if you can get the answers and then continue on to see if it worked. Or if you just want to watch through, that's totally fine too. So on this particular one, I have my sides that I need to label. So 19 is the hypotenuse, 10 is the opposite, 14 is the adjacent. And we did that last class. On this one here, we're looking at 6 being the adjacent, 12 is my opposite, and 15 is my hypotenuse. And it always helps to label these out first, because all sine is, from our previous notes up above here, sine is just the opposite side over the hypotenuse. So if I look here, the sine of this angle theta is just going to be 10 divided by 19. That's my ratio. It's 10 over 19. Cosine is the adjacent over the hypotenuse. So I know what the adjacent side and I know what the hypotenuse is. So I could say that this is 14 over 19. And that's all we're finding today are those fractions, or ratios as we call them. So let's go to the next problem here. Sine is our opposite over hypotenuse. So if I look for the opposite side, the opposite on this one was 12 over 15. And you can reduce these if you want. You could leave it as 12 over 15 for now, or you could reduce it to 4 over 5. Either one of those works. And cosine is our adjacent over the hypotenuse, which in this case is 6 over 15. And again, you don't have to, but you can reduce that. And that gives us 2 over 5. And that's all today is. All we're looking for today are these fractions, or what we call ratios. The two side lengths given the reference angle being divided. And today we're doing sine and cosine. There'll be one more next class, but I just wanted us to get started off with these two for now. If you have any questions, feel free to email or contact me, and we can work through those and get those questions of yours straightened out. But today's practice, again, is just finding these ratios or these fractions based on the reference angle and the opposite, adjacent, and hypotenuse of each triangle. And again, the big thing here today is knowing these ratios and what they are. Sine is always opposite over hypotenuse, and cosine is always the adjacent over the hypotenuse. And then we did 2 examples of those. And so today, all you're going to be finding on your homework or on your practice are these 2 ratios. That's all we're looking for, are just those fractions today. So again, feel free, contact me if you need help, and we'll work through that. Otherwise, good luck and have a good day.